Okay, so this is going to be some additional examples of the graph of the solving quadratic inequalities, and I just pulled a couple of problems that I found. So the first thing we're going to do is we are going to set this equal to 0, so that means I need to add 2 to both sides, and I get negative 3x squared plus 3x plus 6 is less than or equal to 0. And we're going to solve that it is as if it is equal to 0. Quadratic formula seems to be popular, so I'll solve it by quadratic formula. So a is equal to negative 3, b is equal to 3, and c is equal to 6. And that's going to be x is equal to negative b, so that'll be negative 3 plus or minus the square root of b squared. So that's going to be 3 squared minus 4 times a, which is negative 3, times c, which is 6, all over 2a, which is negative 3. Now that I've got all my variables into the formula, I just need to simplify. So it's going to be negative 3 plus or minus the square root of 9. Let's see, 4 times 3 is 12. 12 times 6 is 72. So that'll be positive 72 over negative 6. X is going to equal negative 3 plus or minus the square root of 81 over negative 6. And then negative 3 plus or minus 9 over negative 6. And then this is where we separate it. So x is equal to negative 3 plus 9 over 6 and negative 3 minus 9 over negative 6. And 9 minus 3 is 6, so 6 over negative 6 is equal to negative 1. And negative 3 minus 9 is negative 12 over negative 6, which is positive 2. Now these are not my solutions. These are the critical values. So I need to pick a point in between these two to test to see where the inequality falls. So since I have negative 1 and 2, 0 is a good candidate. So I'm going to substitute in x for 0. That's in between negative 1 and 2. And I'm going to plug it into the original inequality. So negative 3 times 0 squared plus 3 times 0 plus 4 is less than or equal to negative 2. Of course, that equals 0. That equals 0. And I get 4 is less than or equal to negative 2, which is false. So that means my inequality is not in between my critical values, but on either side of it. So x is going to be less than or equal to negative 1, or x is going to be greater than or equal to 2. It's going to be on either side of it. This is my solution. Okay, on the next one, again, I'm going to set it equal to 0, so I'm going to subtract 6 from both sides. So I'm going to have x squared minus 2x minus 6 is less than 0. And I'm going to use quadratic formula again because this is not factorable. So a is equal to 1, b is equal to negative 2, and c is equal to negative 6. Then I'm going to substitute my values in. X equals negative b, which would be a positive 2, plus or minus the square root of negative 2 squared minus 4 times 1 times negative 6. That's my negative 4ac part, all over 2a. 2 times 1 is 2. So then I'm going to simplify from here. 2 plus or minus the square root of 4 plus 24, because I have a double negative, all over 2. X is equal to 2 plus or minus the square root of 28 over 2. And then I've got to simplify the square root of 28. And I'm going to do that by the ladder method, which divides out all my prime factors first. So 28 is divisible by 2. 2 is a prime factor. I get 14. 14 is also divisible by 2. Then I get 7. I know 7 is a prime number, so I'm only going to be able to divide by 7. And there's my 1. That means I've factored out everything else. My 2, 2, and 7, those are the prime factors of 28. And for square root, I want to circle my pairs. The 2 gets to come out. The 7 does not. So now I have x is equal to 2 plus or minus the square root, 2 square root of 7 over 2. They're all divisible by 2, so x is equal to 1 plus or minus square root of 7. Again, this is my critical value. It is not my solution. I need to test a point in between there. So if I put 1 plus square root of 7 and 1 minus square root of 7 into my calculator, I get an estimate. And luckily for us, 0 makes another good test point. So I'm going to substitute in x equals 0 into the original. We're going to have 0 squared minus 2 times 0 is less than 6. These go to 0, so I have 0 is less than 6. This time this is true, so it means that my x is between 1 plus square root of 7 and 1 minus square root of 7. So this is written as a compound inequality. My x falls in between the plus or minus values. And x is less than 1 plus square root of 7 and x is greater than 1 minus square root of 7 is my solution.